Hi all, this is one type of question that may be given in GATE. This question may be applicable to electrical and electronics engineering. Let us read the question first. The continuous time Fourier transform for the signal x of t shown in the figure is x of j omega is equal to a by omega square into cos omega minus cos 2 omega, where the constant a equal to, he has given the shape of the waveform. It is trapezoidal waveform. By seeing question, what are the parameters we can extract from the question? First one is, we know it is continuous time Fourier transformation, and second one is we can calculate area of trapezoidal. So based on these two inputs, we have to calculate a value. Okay, first let us simplify the waveform x of j omega. How we can simplify? He has given a by omega square into cos omega minus a cos 2 omega. So here, for simplification of this equation, we have to use Taylor series. We know Taylor series, cos omega is equal to 1 minus omega square by 2 factorial plus omega to the power of 4 by 4, sorry, yes, omega to the power of 4 by 4 factorial and so on. At the same time, what is cos 2 omega? Just replace omega by 2 omega. 2 factorial plus 2 omega to the power of 4 by 4 factorial and so on. Now, if we subtract cos 2 omega, sorry, cos omega minus cos 2 omega is equal to 1 minus minus of 1 here 4 omega to the power of 4 by 2 factorial minus 2 to the power of 4 means 4 into 4 16 by 4 factorial. Let us simplify. 1 get cancelled. 4 omega square by 2 factorial minus omega square by 2 factorial. So we are left with 3 omega square by 2 factorial, nothing but 3 by 2 omega square. Next one, omega to the power of 4 by 4 factorial minus 16 omega to the power of 4 by 4 factorial. We can see this is nothing but 15 by 4 factorial. 4 factorial means 4 into 3 into 2. So nothing but 24 omega to the power of 4. So x of j omega is equal to a by omega square into 3 by 2 omega square minus 15 by 24 omega to the power of 4. Just I am leaving higher order terms. it will give A into 3 by 2 minus 15 by 24 omega square. Here omega square get cancelled. So now let's go to next one. Yes. So we have simplified x of j omega. Now let us see what is the area of trapezoidal. This is one triangle. This is another triangle. This is one rectangle. So 2 into means two triangles of B. B is this 1 unit. H also 1 unit. This area already we calculated. This area. Now rectangular. Rectangular width is 2. Height is 1. So area of trapezoidal is nothing but 1 plus 2, that is equal to 3 unit square. Now just I am adjusting the screen. Now we got area of the trapezoidal. So we got two inputs. Now how to solve this? So x of j omega, you know, nothing but a into 3 by 2 minus 15 by 24 omega square and so on. So here we have given one hint that it is a continuous Fourier transformation. So how we will do continuous Fourier transformation? What is the formula for x of j omega is equal to nothing but minus infinity to infinity x of t e power j omega t dt. If we replace omega is equal to 0 is equal to minus infinity to infinity x of t e power 0 is nothing but 1 dt, that is equal to minus infinity to infinity x of t dt. We know this is nothing but this is minus infinity, this is infinity. From here to here we are integrating. This is nothing but trapezoidal waveform area. So area of trapezoidal how much? This is nothing but 3. Already we calculated here. From here to you can see area of the trapezoidal is 3 square units, and we know x of j omega formula, and you replace j omega, you replace omega by 0 in j omega. X of j omega means 3 by 2 a into minus 15 by 24 into 0 so on is equal to 3. So a into 3 by 2 is equal to 3, nothing but a is equal to 2. In this way you can solve this problem. So you have to remember basic things. This problem, first one is Taylor series, how you can represent cos omega, cos 2 omega in the form of Taylor series. Second one is he has given a hint that continuous time Fourier transformation. For that you should remember those two formulas. Formulas means x of t in terms of x of j omega, x of j omega in terms of x of t. Those two things you have to remember, and you have to make some observations from the waveform. In this way, you can solve the equation. Thank you.